Hello everyone, this is Professor Pankaj Kumar, Department of Mechanical Engineering, SR University, Warangal. Today I came with a new talk on advanced fuse deposition modeling, that is advanced FDM. In that I am going to discuss about the technology, equipment, part quality and advanced application of the FDM processes. So before that, starting our talk, let me discuss about the after today's class advanced FDM, what student is going to learn those things. So at the end of this lecture on advanced FDM, one will be able to explain advanced FDM technology and machine architecture, and they will be able to understand the equipment and the subsystem of the FDM processes. Similarly, they are going to analyze the part quality issues and their causes. And sometimes we have seen that a part is not manufactured with the perfect quality. So, what are those reasons for that getting down quality and how that issue can be resolved? Those things I am going to also discuss. Now, coming to the other things, industrial applications of the FDM process also will be discussed in today's session itself. And after that, one will be going to identify what are the advanced concepts such as multi-material printing. In that case, we know about how to manufacture the like 3D printing composite material. For that, we require dual nozzle. So from that dual nozzle, from one nozzle, one material will come, from another nozzle, another material will come. Or sometimes one material used for the main manufacturing of the part and another nozzle will be used for the support structure. So that is the concept of the multi-material printing process. Similarly, I am also going to discuss about the what are the new concepts related to reinforced filament. And nowadays, customized filament are made. In that filament, the two different materials are mixed together and filament are made. That you can say that it may be composite filament. One will act as the reinforcement, another will act as the matrix material. Similarly, what are the process parameters that can be monitored? Similarly, that can be controlled for getting better quality of the product. That also I am going to discuss in today's session. So one will be able to explain those concepts after going through this lecture. Before starting the main concept, first we will discuss about the what are the basic concept of the FDM process that I have discussed in the previous classes or previous my sessions. So one can go to the my YouTube channel and they can refer to the basic concept of the fuse deposition modeling, and one can get the all detail of about the basic or fundamental of the fuse deposition modeling. So coming to the that previous classes, this is the quick revision or quick recap. So just to go through this video. So you have seen that in FDM process or fuse deposition modeling process, the printing will happen layer upon layer. Yes, when the extruded filament will come from the nozzle and it will be fall on the build platform. So that filament is made from the thermoplastic material. And before that, one has to know about the what are the basic steps of the fuse deposition modeling or 3D printing process or additive manufacturing process. So always in 3D printing process, first CAD design will be used. So that's why I have mentioned about the CAD to slicing to the printing workflow. So in this, there are 7 steps or stages of the 3D printing process. So for in that first stage is the CAD modeling. So CAD modeling can be done using many CAD available softwares like Fusion 360, like SolidWorks, CATIA, ProE, There are many other softwares from that one can make the 3D design, and that design is nothing but the what product they are going to manufacture. Yes, with that, so this flow has to be maintained. So first CAD designing, after that you have to save your CAD model into the STL file format. So why STL file format? That already we have discussed about, because the machine which will print this, they require only discussion about the how your like print head should be moving, or maybe stages should be moving in X direction, Y direction and Z direction. So those G code, M code, X coordinate, Y coordinate and Z coordinate variation machine is required. For that we require slicing of entire product layer upon layer. So each layer what information is required for, like contour, X coordinate, Y coordinate, Z coordinate, as well as the rotation, maybe clockwise or anti-clockwise, those detail is required by the machine. For that we have to perform the slicing operation. So once we have performed the slicing operation with the proper parameter setting, so here parameter setting means here what is the printing parameter, like scanning speed, layer height, thickness, infill density, infill pattern, those things during the slicing itself one can give the, so that with that parameter setting slicing will be happen for each layer and for all layers. So after that, that detail file, whatever the sliced information file will saved, that file has to be sent to the machine. That is the next step. In that machine they will get, you can send that information through USB drive, or maybe wire connected will be there, or through pen drive, or through any other Wi-Fi connection one can send. After that you have to load the material, what material you are going to print, that material is loading in the machine, so that when you will start the printing, so that time those material will be coming through the spool and it will be going through the print head, and then after semi melting or melting it will come out from the nozzle in the liquid form and it will fall on the print bed. So printing will happen. Once printing happen, after that what you have to do, you have to take out that printed object or part from the build platform, and you have to do the secondary processing. That is secondary processing, nothing but the post processing operation which is required to remove sometimes support material or to improve the surface quality of the printed product. As we know that in 3D printing process, always part quality will be not as equal to the conventional manufacturing technique. So always you require to improve the surface quality of the 3D printed product. For that you have to perform secondary operation, sometimes we are calling as the post processing operation. Once post processing is done, that part final will be sent for the customers, or finally will be sent for the direct applications. So this is the workflow of the 3D printing process. Similarly, after that also we have seen that deposition through heated nozzle means when the filament will come. So here you can say that this is the printed. So from one end or top end, filament is coming and extruded, and in that heating element will be there. That heating element will melt this filament, solid filament material, and it will come out from the heated nozzle from this way. Yes, and it will be printed like the whatever the design file is there, what is the each layer information is there, as per their printing will happen. So after that already we have discovered solidification and layer bonding will be there. As we know that layer upon layer printing is taking place, so one has to ensure that it should be properly joined. Otherwise, if it is not properly joined in, again it will come at the defective product, or quality of the product will be not as good as expected. So this is the workflow of the 3D printing process. Now coming to the FDM machine architecture. This is a very important concept, because nowadays lot of companies they are developing their own 3D printing machine. Even in the lab itself one can develop 3D printing machine for that, what are the component is required, how that component will be assembled, what is the functionality of each component, each part, those information, and what are the sensor is required, how those censored and like moving part will be controlled, this all information. Similarly, for the manufacturing of the different like structure, what is the quality is required, so those information, this all will come under the machine architecture. Now from this image or this figure, you can see that there are different structure. So this is the first structure, this is the second structure, this is the third structure, like that different other component are also there. This is the printing head, so this is the hot end nozzle. So similarly, this is the print bed. Similarly, this is the filament spool will be there. Over that spool, whatever the filament are used, that filament will be rolled over, and whenever it will be used, that rolling material will come out from this way. And this is the build platform, and this is the heated build platform. Why? Because during the printing we required hot end material will come, so that this temperature gradient between the build platform and the heated material should not much, otherwise joining issue will come, maybe sometimes warpage issue, sometimes other defect will come, that we are going to discuss in other session. So similarly, it is followed, this printing architecture or this 3D printing machine architecture follow the Cartesian coordinate. As we know that in Cartesian coordinate, x coordinate, y coordinate, z coordinate will be there, all will be vertically 90 degree to each other. Yes. So this one can see that this is the z axis, this is the x axis, and this is the y axis. All three axes are perpendicular to each other. Yes. So this we are calling the coordinate system. That's why this is the coordinate, or you can say the Cartesian coordinate system. Now this is the one printing machine. In that printing machine, inside structure they will be looking like that. So here x motion could be there in this direction, so this stage will be moving for the x direction moment. Similarly, this stage can move in this direction, so for y direction motion. So similarly, this stage can move up and down for the z direction. So x and y direction are used for the giving particular contour motion on that layer. Similarly, z motion is given for the different height. So moving for one layer to another layer, so the z motion will be required. So this all motion will be controlled by the stepper motors. That's why here control system is required for controlling the stepper motor. So in that different steps, the control this motor will be moving. So this is the architecture of the 3D printing, generalized 3D printing machine. So in that already I have mentioned about the frame and structural rigidity is required. Why? Because any variation or vibration will lead to the defective product or part quality what is expected after printing, that will not come up. Sometimes also we have seen that printing will be not properly working, maybe stop working. Coming to the motion system, already we have discussed about in this printing architecture, we are using the Cartesian coordinate. In that, x coordinate, y coordinate and z coordinate all will be mutually perpendicular to each other. Similarly, other motion system could be like core xy, similarly delta coordinate system. Now coming to the extruser system refers to printing head. In that printing head, how our solid filament is coming. Solid wire filament is coming from one end and liquid material is coming from another end. So entire system is called as the extruser system. Similarly, in that hot end and nozzle will be there. Hot end nothing but the here inside heating element will be there. That heating element will transfer their heat, whatever the heat is required for the melting of the solid filament. Those heat will be given from the hot end, and from the nozzle the liquid material will come out and it will be printed on the build platform. Similarly, the building chamber. Building chamber is nothing but the what is the volume of the entire thread printing machine. Sometimes we have seen that whatever our product is required, that product volume will be bigger than the thread printing machine build volume or build chamber. In that case, we can't print. So for that case, we have to reduce the or scale down our design model itself. So that design model will fit or what is the maximum volume of that 3D printing machine is there or build chamber dimension is there, that will be fit inside. So sometimes also we have seen that we have designed a small product, but we require more like bigger than that. So in that case, we can scale up and up to maximum whatever the build chamber dimension is there, with that dimension printing may be happened. Similarly, already we have discussed about the build platform, controller and sensors. Now coming to the extrusion system and nozzle technology. So here in this image I have presented different configuration in that how the wire filament is coming, melting and coming out from the nozzle. So in the first image you can see that a wire filament is directly coming and which is like driven by the driving wheels. Both side driving wheels will be there, so that will drive so that the wire filament will move in the downward direction. So this will be the entire heating chamber will be there, and that heating chamber will melt the material, filament material, and it will come out the semi-liquid material and it will be deposited on the, this is the build platform for each, like this is the image A, B, C. So different configuration of the extrusion system. But in this system you can see that your filament material is not there. In that case, powder form of that thermoplastic material are used, and that thermoplastic material will be melted here and it will come out from the nozzle in the liquid form, and it again it will perform the like x coordinate, y coordinate and z coordinate motion to get the different like layers information, and then printing will happen in x direction, y direction and z direction. Coming to the last configuration, in that configuration you can see that here hopper will be there. From that hopper, powder form of the thermoplastic material will be fed, and in that again heating element will be there, and that hopper will drive the liquid material to force out and come out from the nozzle, and it will again perform the like printing as per the slicing or operation itself. So here we require direct drive chamber, Borden extruder, single nozzle versus dual nozzle. Sometimes earlier we have discussed about you can print the part with the two different material. One material used for the printing of the part and one another material can be used for the support structure. This is one configuration. Another configuration, sometimes we are making the 3D printing material, composite material. In that case, we require two different material layer upon layer. So functional graded composite material or some other form of the composite material can be fabricated. So for that, dual system is required. Similarly, the nozzle diameter effect. Sometimes generally 0.4 mm will be the nozzle diameter. But what will happen if you increase the diameter of the nozzle, or what will be effect will come on the material or print quality or part dimension if the nozzle dimension is changed. So those things, as well as the, like suppose you harden the nozzle for the abrasive filament. So nozzle can be made from the like maybe ceramic material or maybe material having the high temperature, melting temperature. So one can think of the like what could be the material. So one can, lot of company nowadays they are manufacturing the nozzle itself. Innovative, they are coming with the innovative material itself. Yes. Similarly, high flow nozzle for the large scale printing, as we discussed, you can increase the diameter of the nozzle or you can decrease the diameter nozzle. So what will happen? The quality of the part. If suppose the bulk amount of the material is coming, so definitely the one layer thickness will be more. If thickness is more, then quality of the product layer effect will come, so it will get down. So similarly, reverse to that, if the nozzle diameter is less, so less amount of the material will be coming, so less thickness of the one layer will be there. So in that case, better surface quality of the printed product can be achieved. Now coming to the build platform and thermal management, this is very important respect to thermal management, because here the heat is generated. That heat is used for the, basically it will be used for the only the heating of the filament material, but there are certain other component in that printing machine itself. Those printing component will be also affected from the heat generated, or maybe that heat is generated inside the build chamber. So that chamber, inside chamber, all component will be there. Sensor will be there, even motion control system will be there, build platform along with the build platform material will be there. So there are other part also that will be affected from the this heating filament itself, heating nozzle heat generated. Because of that, it is very important to understand or to control the whatever the maximum temperature generated inside the build chamber. For that, sometimes we require cooling. There are different way of cooling. You can cool down placing by like some liquid light nitrogen. You can keep some quantity of the liquid or continuous feeding of the liquid nitrogen inside the chamber. Or other way is that you can like mount the some like fans, cooling fans, so that cooling fans will take out the heat generated inside the build chamber, so that whatever the optimal temperature is required in that third printing build chamber, so that will be maintained, and all part of that inside chamber will be functioning properly. Now you can say that that's why. And also sometimes also we have given the heating to the build platform also. From that heat will be also. So major source of the heat generation will be there inside build platform as well as the printing head. So those temperature combined effect will come. For that we require like insulating material, we require cooling like chamber, cooling of the chamber. It can be like liquid supplied, liquid nitrogen supplied, or some other gases can be supplied, or it can be like cooling fan will be there. That cooling fan will take out the heat and it will maintain the environment temperature at constant, so that our part will be, or 3D printing machine quality part will be functioning very properly. So these are similarly what are the effect will come. So sometimes during the printing, if suppose the printing head temperature is more and this build temperature is very less, so thermal gradient will be developed. That due to that thermal gradient, here warpage effect will come. In the right side image you can see that this side and this side both are like leaving the build platform. Because of that, what will happen? Proper joining in the build platform will be not taking place. And similarly, also a delamination effect may be also come. Because of the delamination, also layer upon layer separation will be starting. So always, so that will be come under defective product. So that's why thermal management is very important. So one has to ensure that whatever the optimal temperature in that build chamber is required, so that temperature maintaining is required. In that case, cooling of the chamber is required. There are various way of the cooling chamber. Now coming to the what are the defects. Earlier just I was discussing about the various defects in the 3D printing machine. So those are like warping. So warping is nothing but the, it will like build platform and then the first layer will not join properly, so that lifting of the from corner or side of the printed material from the build chamber. So because of that, lifting this way, lifting or left side or lifting any side direction, lifting from the build platform is called as the warping issue. If the warping issue is come, so after 2-3 layers itself, printing will stop. So you will face problems. So printing will not. So because of that, so similarly thermal shrinkage will be there. Thermal shrinkage, as we have discussed about, nozzle material will coming out in the liquid, and after that solidification will happen. Because of that, shrinkage will come, because solidification is coming. So some solidification, less material will be there because of the shrinking. So that issue will come. Similarly, poor bed adhesion. Just I was talking about the warpage also. Warpage is also similar to the like adhesion, properly not adhered the like first layer material, second layer material on the build platform itself. Similarly, delamination, earlier just I was discussing, layer upon layer separating phenomena will happen. If any layer, any product layer upon layer separation part happen, in that case part will be damaged only, not quality we are meeting. So that will be defective product and it will be sent out for the rejection itself. Similarly, poor bonding, low temperature, fast cooling. So these are the different like causes of the defects. Similarly, under extrusion, sometimes the nozzle clogging will be there, or sometimes insufficient flow of the material will come. If suppose nozzle is clogged, in that case what will happen? Proper how much quantity is required supposed to come out from the nozzle, that will not come. So insufficient flow of the material will take place. So maybe proper how much layer thickness is required for one layer, that will not achieved. So printing may be again defective product or maybe stopped. So sometimes over extrusion. So over extrusion reverse of the similar to the under extrusion. So whatever the one layer thickness material amount is required to extrude from the nozzle itself, more than that will come. So uneven surface thickness will come because of that also. Similarly, excess flow of the material, here it will come. And because of this, we have seen that the quality of the product will be getting down, because layer effect will be not uniform, uneven, sometimes higher thickness, sometimes lower thickness, variation will be there. Because of that, uneven crest and truss formation will be taking place. Because of that, surface roughness will be higher. If any higher surface roughness will be there, so that will be sent for the rejection. Customer will not want. They want very good product having the good surface finish, functionally working perfectly. So similarly, sometimes we maybe because of the vibration, as earlier we have also discussed about the maybe part vibration will be taking place if they are not properly rigid. Because of that, defects will come. So these are the different possible defects existing. There are some micro level like possible defects also possible, like inside like the void formation, maybe uneven distribution of the material. So there are various other causes also possible. Now coming to the what are the different method to improve the part quality. Always part quality means your print like quality in the X direction, Y direction, Z direction, you should be uniform, and optimal temperature is required, so that uniform sticking or maybe adhesion with the of the like extruded material with the build platform, or layer upon layer adhesion also, or bonding layer upon layer should be also perfect. For that, you require optimization of the print temperature. So one has to know about what during the like some trial, one can know about what is the optimal printing temperature will be there. So optimization they can work on that. After that, they can set this printing temperature is perfect for the printing of that part. Similarly, proper bed leveling and calibration is required for avoiding vibration effect. If vibrational effect will come, maybe part is not printed perfectly. So similarly, the reduced cooling of the certain material is required, as I was discussing about in the previous slide itself. You have to maintain the uniform temperature inside the build platform or build chamber. Similarly, improve the build orientation. Earlier we have discussed building can be done in Z direction, layer upon layer. Yes, for one certain product. Suppose you can print this pen in the vertical direction. This is one orientation of the printing orientation. So on the, suppose this is the bed, on that bed printing will be taking place, and this way printing will be taking. So this is one orientation. So similarly, printing can be taken with that some angle also, inclined through from the this build platform, or you can perform the printing like this. So one has to know in which orientation the quality of the product, time taking and other features is optimal. Accordingly, the part can be oriented during the printing process, before starting the printing process. Similarly, increases cell thickness. Sometimes a warpage issue and some other issue is coming. So one can increase the cell thickness. As we know that in 3D printing process, first cell formation will be taking. Means here the entire contoured first cell will be printed. After that, inside only contour printing will be taking place. So boundary formation will be there, or cell formation will be there. So sometimes we have to increase the cell thickness. Similarly, one can optimize the infill pattern, infill infill design, or infill percentage also, or infill density, raster angle. So by changing these are the things, one can get the better quality of the product. Sometimes we require post processing or hygroscopic filament effect. So these are the things one has to maintain. So now coming to the mechanical performance of the anisotropic material. As just I was discussing about, you can print the any product in any direction with the inclined or maybe vertically 90 degree to the build platform, or it can be horizontal printing. So this way, this orientation. So depends upon the what is your target application, how that load will apply on the printed product. Based on that, one can decide the what is the orientation of the product. Now coming to the one horizontal printing. Suppose in one application this pen is required high tensile load application. So in that case, one can go for the printing like this. Why? Printing will be taking in the Z direction, layer upon layer. So layer effect will come in the Z direction, and load is applied like this. So what will happen? This entire body will be extended. There is no layer in this way, so there is no separation of material from one end to another end. But the same thing, same material, if suppose you have printed like this, what will happen? Layer will be coming like this, and now you are using for the high tensile load application. So what will happen? This separation of each layer may be taking place because of the high load application. Because of that, your part will be going to field in less load itself. That's why the anisotropy and mechanical performance is very, very important. Similarly, the XY direction stronger than Z direction, as just I was discussing. Layer interface are weakest in one region. Yes, influence of the raster angle, role of infill pattern and infill density and cell thickness, relation between the bonding and the. So these are the properties that will affect the final part quality or final part strength, hardness and other mechanical properties. So coming to the simulation and digital approaches for the FDM process. One can perform thermal simulation, how much heat is generated, how much heat is flow from one end to another end, in between there are different parts, so that how the heat is flowing over that component. that phenomena can be also analyzed. Similarly, a distortion of the part, for that one can perform like load application, static and dynamic load application. There are various software in that one can perform the static and dynamic load application. Yes. Similarly, tool path optimization, residual stress modeling, mechanical simulation on the printed part, make machine learning for the parameter optimization, digital twin concept in additive manufacturing. So these are the various concept approaches should be there for modeling and simulation. One can see that how this will affect. Now coming to the design for additive manufacturing, as I was discussing about the part orientation. As we know that our customer will require very good quality product only. So for that, as a shop supervisor or engineer, you have to make sure that customer should receive the good quality product. For that, you have to design the product, or you have to orient the product, you have to change the layer height, or you have to change the infill pattern, infill density, and maybe some lattice type, lattice structure, how much tolerance is required, optimal orientation is required. So those things, sometimes internal channels is required to make for the very complex geometry design will be there for that. So similarly, the how much allowance is required. Part consolidation is nothing but the how many part is assembled together. Maybe in one printing all part is not possible. So you have to do the study so that how many optimal number of the different part is required, and that all different part should be printed differently at different machine itself, and after that they will be assembled together. That will come under the part consolidation. Similarly, topology optimization, as we have know that sometimes in some area load will be not highly applied. So load applied is not there. In that case, one there will be less chances of the getting part material in that area. So one can reduce or make the topology optimize, so that less quantity of the material will be given by making of the lattice structure, or by making of the removing of the unwanted material, so that here material saving will be taking place, as well as printing time saving will be there, printing machine energy saving will be there. So this way one can go for the design for the additive manufacturing. There are various concepts that I will be separately talking about the design for additive manufacturing. One courses will be there. In that I will be taking more than 10-hour courses. Now coming to the end of this lecture, just I am giving few questions to the audience. They can refer these questions, so that whatever the learning outcome is there, so better understanding will come. So first is that why FDM parts are anisotropic in nature. First question, I have given the example of this printing in the different direction, different orientation. Similarly, how does chamber temperature affect the part quality? Those things also I have discussed in detail. Just go and refer and try to understand. Similarly, what is the difference between standard and reinforced FDM filament? So during the lecture I have discussed about the making of the composite filament itself, or maybe two nozzle will be there. From that one nozzle main material will come, another nozzle another material will come. So this way layer upon layer different nozzle will be used for the printing. So functionally graded material or composite material can be fabricated. Similarly, why this process monitoring important in advanced FDM is there, because You just should discuss about what are the parameters of the 3D printing process, how those parameters will affect the quality of the product, yes, printed product, and similarly name the two emerging concepts beyond the conventional FDM process. Those things. Thank you very much for listening the video. I hope you enjoyed this session. Thank you.